Hello, and welcome back to Mr. Powers Teaches Algebra. Today, we are not talking about vertical or horizontal shifts as we have been, but instead, we're talking about what you see on my screen right now. We're talking about reflections. Reflections about the x-axis, reflections about the y-axis. Those are the two rules. You can memorize them if you want. They're very easy to memorize. However, if you're like me and you're lazy and you enjoy math, often if you enjoy math, you're lazy. I feel like there's a little bit there, but maybe it's a different type of laziness. There's a special type of laziness that us lovers of math have. It's learn slow. Is that I don't remember. But anyway, here. So let's read these and then see if these make sense. I like to make sense of things. So given the graph of f of x, then let's see here. Then the graph of g of x equals negative of f of x. Okay, so what if we start with f of x, put a negative out front of it? What happens? Then the graph of f of x is reflected about the x-axis. This means that the signs on the y-coordinates are changed to the opposite sign. Well, that makes sense since f of x is like our function values, and so now they're all going to be opposite of each other, so it's flipped. All our y values are flipped, so that makes sense. Go over the x-axis. Given the graph of f of x, then the graph of g of x equals f of negative x. So now what if I put a negative in the function? I'm messing with my x values. So now a positive x value has become a negative x value. Negative x value has become a positive x value. That's getting flipped around the y-axis. So I digress. Given the graph of f of x, then the graph of g of x equals f of negative x is the graph of f of x reflected about the y-axis. This means that the signs on all the x coordinates are changed to the opposite signs. Yes. And so let's go ahead and take a quick look at this. This is a good example, I think. One that's good to use for this is the square root function, so square root of x. If I do, let's see, what's the first one? Negative. Negative of f of x. Let's move that. Negative f of x. Look at that. I just negative f it. It would do it too. What does it do? It puts a negative out front of my function. So negative of square root of x. And as you can see, let's make that a little bigger, we get, it gets flipped over. Now I got my whole thing. I got my whole parabola. But look, it gets flipped over our x-axis. Because now every value, before I had 4, 2, now I have 4, negative 2. Because I'm taking all the values that I had before, but I'm getting the opposite of them. So it's getting flipped. And we could look at a table of values on this. And we would see that the y values are just becoming negative. Well, this is the opposite of them. There are no negative values in the absolute value functions, but if there were, it would do it as well. Let's see here. What else could we do? So the other one we had was, let's remove. Let's go ahead and delete this. We also have f of negative x. So, okay, let's take a look at that, see if this can make sense to us. And so what does that give us? In this case, we're changing x to negative x. Well, in every case, that's what we're doing. So instead of square root of x, we have square root of negative x. All right. So we can look at these. And we have this beautiful little function here. We can see that, we're getting this reflection over our y-axis. And why is that? Well, because when I usually would plug in 1 in my square root of x, that 1 is becoming a negative 1. In this, well, what's square root of negative 1? You can't do square root of negative 1. So I can't plug in 1. I can't plug in 1 into this function. If I plug in 1, I get a negative under the square root. It's no good, right? None of those are good. But now if I plug in a negative 1, what's a negative of negative 1? If I plug in negative 1, negative 1 is 1. So now I can take the square root of that, and it's the same as 1 as before. Square root of negative 4, in other words, square root of 4 is 2. So you can see we get this reflection. And it makes sense. We're messing with our x values. We're messing with the x-axis. It's going to flip over the y-axis. And again, we can look at the table if we like. Maybe that'll help. Here we don't have a lot of negative values in our table, but let's go ahead and put some in here. -1, -2, -3, -4. Actually, -2. That's not a pretty one. Let's get rid of those. Here, -4, -9. There. Right, we got these values. Oops. And before we had them over here for the positive values. Square root of 1 is 1. Square root of 4 is 2. Now, square root of -4? No, right? Because g of x is square root of -x. So square root of 4 again is 2. Square root of 9 again is 3. So on and so forth. Okay. So that's really neat. So there's a couple examples there of some reflections and how those work. So that's all I have for this video. Hopefully you got that down. Until next time, enjoy doing math.